In this lesson today, we're going to review key features of a parabola. And so this first one, we're going to review what is the domain and range and where do you find the vertex. You write down in your notes whatever you need to. So whatever you're not quite sure about, I put in your notes. Whatever you feel really confident about, you're welcome just to listen and watch. This is the vertex. Every parabola contains a vertex. The vertex is sometimes called the turning point. So I'm going to write that down. The vertex is sometimes called the turning point. And the reason for that is because vertex, in this case, looking at this parabola from left to right as we analyze it, you're declining or going down, your vertex is always neutral, and then you begin going uphill or increasing. So your turning point is where it goes from decreasing to increasing. Remember, your vertex is neutral, so turning point. In this case, our turning point has a vertex of 2, 3. 2, 3. Now there's two parts to the vertex, the x and the y. The y-coordinate of the vertex is also known as the minimum or maximum value on a graph. The y-coordinate of the vertex is known as the minimum or maximum value on the graph. So in this case, since the parabola opens up, we could say the minimum value of this parabola is y equals 3. Domain and range in interval notation. So as this moves up, it's being pulled to the left, and as it moves up on the right, it's also being pulled, as it moves up, it's being pulled to the right. So it's being pulled in two directions, and that's how you get this diagonal of the parabola. There's no limit how far it goes to the left, and there's no limit how far it goes to the right. So the domain is negative infinity to positive infinity. The range, you always go with the smallest followed by the largest. The smallest y value is 3. There's no limit how high it goes up to positive infinity. It does touch at 3. We can't actually touch infinity. It's not an actual number. Okay, this next one. Within your groups, I'm going to pause right now. For this graph, the vertex has the coordinates of you're going to go over 2 and down 1. So negative 2, negative 1. And just as a quick review, if they said to you, what is the maximum value of the graph? It's going to be the y value. So the maximum value, if they would have asked, would have been y equals negative 1. Domain, there's no limit how far it goes to the left. There's no limit how far it goes to the right. Negative infinity to positive. Range, we always start with the lowest and we go up to the highest. That may be a mistake many of you made. So the lowest here, there's no limit how low it goes, negative infinity, but it does go up as high as what y value? Negative 1, and it does touch at that point. Now, when you do increased and decreased intervals, there's 3 things I would like you to write down if you don't know them. Here's the first thing. We learned this during Unit 1. The first thing I would like you to write down is that we only use parentheses. When you are examining a graph and you are identifying increasing and decreasing intervals, you only ever use parentheses. That's the first thing I'd like you to know. The second thing is you only describe it in the intervals with x values. You're only describing using x values. So always use parentheses, always use x values, and then you're going to evaluate it from left to right. From left to right. So I'm going to start over here. Picture yourself running here, and from left to right, what would you be doing? You would be going from left to right. What are you doing? You're going uphill. Well, another word for describing uphill is increasing. And then you hit the turning point, also known as the vertex, and now you're going downhill, which is decreasing. So, only ever use parentheses. I'm going to start with that. Only ever use parentheses. And now in terms of x values, you're coming from the very far left here. So describing this in terms of x values, coming from the very far left. And you continue to increase until you get to this turning point, also known as the vertex. What is the x value there? Negative 2. Now, after negative 2, when you move off this high point, you start to go down or decrease. So from negative 2, now here's where a lot of mistakes are made. In terms of x values, it's positive infinity as you go to the right. Most students want to write negative infinity because they see it going down. but describe it in terms of x values as you go to the right. As you go to the far right with no limitation, it would be a positive infinity. So again, this vertex is neutral. It's neither increasing or decreasing. We call it a turning point because you go from increasing to decreasing, or vice versa if it was pointing upward. Okay, let's look at the next one. I'm going to give you 1 minute as a group. Please go over vertex, domain, range, increasing. All right, the vertex here can be found by going to the left 5 and up 3. Vertex is -5, +3. Once again, as a reminder, if they asked you what would be the minimum value of this graph, it would be y equals 3. Y equals 3. You can't just say 3, it's y equals 3. Domain, no limit to the left, no limit to the right. Range, it goes down as far as +3, no limit how high it goes. Make sure at the 3 we do have a bracket because we're including it. From left to right, what are we doing at this point? We are going down, so I would identify this as decreasing. This is our turning point at the very bottom, and then it turns from decreasing into increasing. Remember, in terms of x values, so increasing first. It starts at an x value of -5. There's no limit how far it goes to the right as it increases. Always parentheses. Decreasing, it comes from the far left, -infinity, and it continues to decrease until it hits an x value of -5. Okay, mini lesson number 2 is going to talk about, it's going to go over vertex again, but we're going to really review end behavior. So how do we set up end behavior? In my experience, most students understand when I explain it. What they struggle with is how do I write it myself? So I always start generally with -infinity followed by positive. So every problem looks like this, and then in this position, which I'm just going to write a really light question mark, we're going to fill that in. What options do we have for answers? Well, when we look at the very ends of our graphs, one of 3 things are going to be happening. It's going to be going down, it's going to be going up, or it's going to be staying constant at some value. So here we go. This means look at the very far left of your graph, so way over here. And if you're going to describe what's happening, the graph is headed down. How do we write headed down? -infinity. On the far right-hand side, what's happening? It's also headed down, -infinity. All right, so right here, I'm providing you with a graph, and I would like you to come up with the vertex and the end behavior. So the vertex of this graph would be from the origin. You're going to go to the left 4 and down 3. Left 4 and down 3. Once again, will we describe this as a minimum or maximum value of the graph? It is a minimum. It's the lowest point. So if they said what is the minimum value, it would be y equals -3. All right, so I'm going to set up the end behavior. This means as I go to the far left, what's happening? Way over here, we can see the graph is headed up. And if I go to the far right, we can also see in this case it is headed up. Now what you're going to learn about parabolas, look up here please, is parabolas are always going to be going in the same direction. Do you see how they're both going up? Both going up. Now they're both going down, both going down, or both going up. So when we would do the end behavior for a parabola, these will always be the same. How do you know if they're positive or negative? It's depending if your parabola is opening up or if your parabola is opening down. In 9th grade, you learned about, you're going to probably want to write this in your notes, you learned about rate of change. And we're going to write average rate of change. So it's like taking a snapshot of only one piece of the graph. So in this case, I'm going to go and I'm going to write from -4 to -2. If I asked you for the average rate of change, what that means is I go to where x equals -4, okay, right here, and where x equals -2 right here, and I want to know on average what's happening. Well, is it increasing or decreasing from left to right in what I highlighted? It's increasing because it's moving upward, so I know it's going to be a positive value. Now, how fast is it increasing? Here's how you decide that. This is an interval. It's not an ordered pair. So negative 4, I leave a space, and negative 2, I leave a space. Negative 4 happens to go with the y value of negative 3, and negative 2 corresponds to 0. x1, y1, x2, sorry, y2, y1. Then I use the slope formula, and I substitute in the numbers. So y2 would be, oops, sorry here. There we go. y2 would be 0, subtract a negative 3, 0 subtract negative 3, and negative 2 subtract negative 4. Two negatives make a positive, and negative 2 and positive 4 is 2. So this is the same as 1.5. So on average, for every unit I move over, it's going up 1.5 on average. From negative 4 to negative 2 on this graph, for every unit I move over, it's going up 1.5 up. Okay, let's look at the next one. So before we do this, I'm going to say this time we're going to first practice average rate of change. For this particular graph, I want to go from 2 to 3, and I'm going to help you out because it's hard to see. Within your group, I'm going to give you 30 seconds to figure out what is the average rate of change on the interval from 2 to 3. Show all of your work. So from 2 to 3, I can see that it is increasing, which means it will be a positive answer. Now I need to figure out the corresponding values for 2 and for 3. 2 corresponds to 1, 3 corresponds to 7. x1, y1, x2, y2. Plug it into the slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. 6 over 1 is an answer of 6. All right. So does this particular problem have a minimum or maximum value? Has a minimum value. And what is the minimum value? I'm not going to write negative 1. The minimum value is y equals negative 1. Y equals negative 1. And increasing and decreasing, I'm going to pause this and I'm going to give you 20 seconds. Take it like a checkpoint quiz. Please write down the intervals for increasing and decreasing on this graph. For this graph, I can see that as I come from the left, that's how we're going to analyze this. It's going down, so it's decreasing. Then I hit that turning point, which is neutral, and it turns into increasing. So it decreases coming from the far left to an x value of 1. And then it turns and begins to increase from 1 to 2. This next part is we are going to learn how to find the intercepts of an equation by not looking at the graph, but algebraically how to find it. So the first thing is, let me give us a different equation than what we see right here. Let's start with this one. Let's write down y, please this is in your notes, y equals x squared minus 3x minus 5. Please write it down. All things you've learned before. So the easiest one is, how do you find the y-intercept of a graph? X is always 0 when you're finding the y-intercept. I'm going to show my work. You'll be able to do this with mental math if you choose later on. I'm going to substitute a 0 in wherever I see an x, and I'm going to do the math. 0 squared minus 3 times 0 minus 5 is a negative 5. I want to write my final answer as an ordered pair. Again, x is 0, and in this case, y is negative 5. How do you find the x-intercepts of a graph? Well, y is always 0. Now, the first thing we should do is check, can we factor this? Because if we can factor it, life is going to be so much easier. So let's check this out. Am I able to take, well, let's see, 3 times negative 5 is negative 5. Are there two numbers that multiply to equal negative 5, but somehow combine to give us negative 3? Well, the only numbers that multiply to give us 5 would be 1 and 5, correct? And can 1 and 5 somehow give us a negative 3? Not possible, so it's not factorable. When it's not factorable, you're going to use one of two methods. You're going to use completing the square, which we're going to review a different day. You learned in 8th and 9th grade. Or you're going to use the quadratic formula. If you haven't memorized it, now's the time you have to. You have to know it by tomorrow. Please write this down if you do not have it memorized. quadratic formula will give us the x-intercepts, if they exist, the x-intercepts. And I'm hoping for some real x-intercepts, not some complex, because we haven't learned that yet. We'll learn that during this unit. Okay, within this equation, a is in front of x squared, b is represented by what's in front of x, and c is the constant. So for this problem, a is 1, b is -3, and c is -5. Now, I'm going to show a minimal amount of work, because I'm going to use my calculator to do just a little more complicated math. X equals, this -b says, take whatever b is and change the sign. So instead of me writing down -3, I change the sign, and it's a +3, bringing down the plus or minus. Please leave it blank inside. That's a discriminant, which we will figure out on a calculator. On the bottom is 2 times a. Well, 2 times 1 is 2. Grab your calculator and turn it on. And please follow along with me. I'm going to start with the parenthesis, and I'm going to type in what b is. So -3, and I'm going to end the parenthesis. And then to square it, you're going to find that key on the left-hand side. You can see where I'm hitting it. Subtract 4, parentheses, my a is 1, end parenthesis, and my c is -5. The negative sign can be found below the 3. And press enter. 29. Before I can write a final answer, I need to ask myself this. Okay, are you ready? Listen closely, put your calculators down. Raise your hand without saying, verbalize it, raise your hand when you know the next number. 1, 4, 9, hands up when you know the next number without saying it. Okay, go ahead, Claro. Take a guess, Claro.
14.
You're close. Okay, you're getting real close. I'd say to my son, warmer, you're getting warmer.
16.
Oh, there we go. Kaylin, what's next? Anais. Eric. Vanessa. Pedro. Anybody else? Close. Did you say 25? Good job, Pedro. Where am I coming up with these random numbers?
I don't know. Those are the numbers that I squared.
Perfect squares. 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. What's the next one? 36, 49. Now, you're like, why are you coming back to this? We already learned that in Unit 2. Because before you can finalize an answer, we're working with a square root. Square root, I need to look at the perfect squares. 29 lies right here. So I'm going to look at all the numbers before it. Does 25 nicely divide into 29? No. Does 16? No. Does 9? No. Does 4? No. Yes, 1 does, but it doesn't reduce anything. Which means I now can write my final answer. I have 2 perfect squares, and I know that because I have a plus or minus. So the first one I'm going to write is a plus. And the second x-intercept, I'll use the subtraction sign. And remember, with x-intercepts, y is always 0. Those are my answers. Okay, so at home, if you're watching this video, please write down f of x equals x squared minus 5x plus 3. Please start right now, whether you show work or not. You have 10 seconds to identify the y-intercept. Ready? Begin. So some of you are already done. Some of you are already done. So hold up 1 second here. What is always, when you have a y-intercept, what's always true? We're going to get to that in a second, Pedro. That's good. That's the shortcut, Pedro. But what is always true? X is always 0 when you're finding the y-intercept. And what Pedro said is another shortcut. The constant, when it's in standard form, the constant is always the y-intercept when it's in standard form. So the y-intercept here is y equals 3, written as an ordered pair, is 0, 3. What are the only 2 combination of numbers you can multiply to get 3? 1 and 3. Do those numbers somehow combine to give you a -5? So when it's not factorable, which are the type of problems you're going to see right now, it's the harder type, we're going to rely on the quadratic formula. So A is 1, B is -5, and C is 3. Remember, negative B means just take whatever B is and you're going to change the sign. Please use the discriminant, which is the value underneath the square root. Just leave it blank. And on the bottom is 2 times 1. Okay, grab your calculator. We're going to start with the parenthesis and typing in -5 and parenthesis and squaring it. Subtract 4 parenthesis times a, which is 1, and parenthesis, and begin another parenthesis, times 3, and then parenthesis, and press enter. And our answer is 13. So I'm going to put a 13 over here. Okay, 1, 4, 9, 16, I can stop. 13 is in between 9 and 16. Do any of these numbers to the left of 9 nicely divide into 13? Nope, yes, 1 does, but it doesn't simplify it any further. So this is my answer, which means one time I'm going to add, one time I'm going to subtract, and 0 in both cases is going to be the y coordinates. All right, as a group right now, you are going to have 2 minutes to find and identify the x and y intercepts of this next problem. Begin. Some of you may say, what is standard form? It's when you have an x squared, then some x value, followed by the constant. So in this case, we get to cheat. We know, okay, there we go. There is the y-intercept. So y equals -9. 0, -9 would be the actual coordinates of it. Now, what if it wasn't in standard form, like in vertex form, in which it looks something like this? If you're looking up here, just hold up for a second. Can everybody stop what you're doing? If it wasn't in standard form, what can you do? Well, you still plug in a 0 for x and do the math and then to get the answer if it's not in standard form. Combinations that multiply to give you 9, 3 and 3 and 1 and 9. Regardless of which one's positive and which one's negative, there's no way to get a combination that combines to equal -3, so you need to use the quadratic formula. I'm going to take the b here and change the sign, so 3 plus or minus. At this time, leave the discriminant by itself, and 2 times 1 is 2. All right, parentheses, -3 quantity squared, subtract 4 times 1 times -9, and the answer is 45. 1, 4, 9, 16, 25, 36, 49. Here we go.
This is the end of first lunch.
Do any of these numbers, except for 1, do any of them nicely divide into 45?
9.
9 does. 9 times what? So if you don't do that, it means your answer is going to be wrong because it's not completely simplified. Square root of 9 is 3. And now I have 2 x-intercepts, one using the plus symbol and one using the subtraction symbol, both containing a y-intercept of 0. So we're going to practice putting all these together as we analyze this quadratic equation. What is the vertex, the coordinates of the vertex? I'm going to go to the right 4 and down 4. So 4, -4. Do I have to show any work for that? Just put my answer. Now here's a tough one. What is the equation of the axis of symmetry? That means, where does it split this parabola in half? Well, it happens at an x value of 4. An x value of 4. It has to be written as an equation. If you just write 4, it would be wrong. The y-intercepts. Can I tell by looking at this graph where it cuts through the y-axis? But it's in standard form, which means the answer can be seen easily. So it is y equals 12. So 0, 12. By looking at the graph, can I easily identify the x-intercepts? Yes or no? Then I don't need to do any work. X-intercepts would be 2, 0, and 5, 0. The domain, there's no limit as it goes to the left or right. The range, it goes down as -4, no limit how high it goes. We do include -4. From left to right, what's happening right now? It is going down, and then it hits a turning point and begins to head up. So as we go down, we consider that decreasing. After the turning point, it is increasing. I'm going to start with decreasing. Comes from the far left and continues to decrease till it gets to an x value of 4. Increases after at least 4, no limit how far it goes to the right. Average rate of change. Remember, these are both x values. So over here I'm going to write 1 and 3. What y value corresponds to 1? Well, if you can't see, please pay attention. This is going to be on your homework. If you can't see, you come over here and you plug 1 in. Please do the mental math for me right now. When you plug in 1 for x, you have 5 seconds to give me an answer. Go. What is the answer, Luis? Do the math.
5, 4.
Is it 4 or 5? 1 squared is 1. Minus 8. Well, 1 minus 8 is negative 7. Negative 7 plus 12 is 5. Okay, let's check 3. What does 3 go with? 3 goes with negative 3. So once I've figured out the corresponding y values, I can plug it into the slope formula to figure out the average rate of change. Negative 3, subtract 5, 3, subtract 1. Negative 8 over 2 is negative 4. On the interval from 1 to 3 has an average rate of change of negative 4. Does this have a maximum or a minimum point? A minimum. And what is the minimum point? Y equals negative 4. End behavior. Just because we're running out of time, as I go to the far right, it's headed up. And as I go to the far left, it's headed up. So it would look like this. In both cases, as I go to the far right and the far left, it is headed upwards. So facts about parabolas. Every parabola contains exactly one y-intercept. Every parabola contains exactly one y-intercept. Parabolas can contain two solutions. They can contain one solution.
All students should be in class at this time.
Or no solutions. Now the word solutions, x-intercepts represent solutions, zeros, and roots. So these are interchangeable words. X-intercepts, solutions, zeros, and roots are interchangeable. If you don't know that, you're writing down what you don't know. Every parabola contains a vertex, and the y-coordinate of the vertex represents the maximum or minimum value. The vertex is also called a turning point on the graph, in which the graph switches from increasing to decreasing or